Hello, and welcome back to Cars Chemistry Tips. Today we will be discussing how to identify what are known as redox or oxidation reduction reactions. This session covers how to identify redox reactions. Redox reactions are reactions that involve the transfer of electrons between chemical species undergoing a chemical reaction. In such reactions, some components end up being oxidized and others end up being reduced. But what does that actually mean? Reduction refers to the gain of electrons, while oxidation refers to the loss of electrons. Now that we have defined the terms, reduction and oxidation, let's consider some examples of redox reactions that you might encounter and learn how to identify them. Some common examples of redox reactions are the combustion of methane gas, the oxidation of copper, and photosynthesis. The steps for determining whether your chemical equation is a redox reaction are as follows. First, we check for ions. Is there formation of ions from free elements? If there is, that is our first hint that a redox reaction is occurring. Next, we use oxidation numbers. We assign oxidation numbers to the atoms on the reactant side of the equation and on the product side of the equation. Let's now consider an example. In this case, we have the combustion or burning of methane. The equation for that is CH4 gas, which is methane gas, plus molecular oxygen, or O2 gas, and that yields two products, carbon dioxide, or CO2 gas, and water, two molecules of water, H2O. On the reactant side, we have methane and oxygen. Methane is a covalent compound and oxygen is a diatomic molecule. During combustion, methane reacts with oxygen to form carbon dioxide and water. The next step is to assign oxidation numbers to the atoms in the reaction. Note that none of the molecules in our equation are charged. In other words, all of the molecules are neutral. Also remember that the sum of the oxidation numbers of all the atoms in a neutral molecule is 0. So let's go back to our equation, and let's first consider methane, CH4. The oxidation number of hydrogen is usually +1 when it is bonded to a nonmetal. Since carbon is a nonmetal, the oxidation number of each hydrogen is +1. Since there are 4 hydrogens, the total is +4. This means that the oxidation number of carbon is -4. Let's now consider oxygen. O2 is a diatomic molecule, so each O atom will have an oxidation state of 0. Now let's consider carbon dioxide, CO2. Each oxygen atom usually has an oxidation state of -2. Since there are 2 oxygens, the total is -4, which means that the oxidation number of carbon is +4. And now let's consider water, H2O. Hydrogen once again has an oxidation state of +1. Since there are 2 hydrogens, the total is +2, so the oxidation number of oxygen must be -2. Now let's evaluate the changes in oxidation number in going from the reactant side of the equation to the product side. We can use the mnemonic oil rig to decide whether an oxidation or reduction has occurred. Oil rig stands for oxidation is loss and reduction is gain. With that in mind, let's analyze the changes. In methane CH4, carbon goes from an oxidation state of -4 to an oxidation state of +4 on the product side. Thus, it gained 8 electrons. Using the mnemonic oil rig, we can see that this is a reduction because reduction is gain in electrons. Let's now look at oxygen, O2. We went on the reactant side from an oxidation state of 0 to an oxidation state of -2 on the product side. Therefore, it gained 2 electrons, and this is again a reduction. Let's now look at CO2, or carbon dioxide. It goes from an oxidation state of +1 to 0. It lost 1 electron, and therefore this is an oxidation. And now looking at water, H goes from an oxidation state of +1 to an oxidation state of 0. This means that it lost one electron, and this is again an oxidation. Overall, we can see that methane is oxidized and oxygen is reduced. Therefore, we can say that the combustion of methane is shown to be a redox reaction. We saw that electrons were transferred between atoms and that there was both oxidation and reduction. Let's consider another example, the reduction of permanganate ions by iron +2 ions. First, we check for ions. We have two non-hydrogen ions involved in this reaction on the reactant side of the equation. One is the permanganate ion MnO4-, and the second is the iron +2 ion. Now let's assign the oxidation number, starting with the permanganate ion. Oxygen has an oxidation number of -2. The sum of the oxidation numbers in MnO4- must be equal to the charge on the ion, which is -1. Therefore, the oxidation number of manganese must be +7. Now let's look at iron +2. The charge on the ion is +2, and therefore the oxidation number on the ion is also +2. We can now evaluate what occurred using oil rig. Recall that the species that loses electrons is being oxidized. In this reaction, iron +2 ions lose electrons to form iron +3 ions. Therefore, iron is being oxidized. Likewise, recall that the species that gains electrons is being reduced. Permanganate ions gain electrons to form manganese ion, so permanganate ions are being reduced. Thank you for joining us in this edition of Cars Chemistry Tips. Today, we've zoomed in on one remarkable process, which is combustion. Whether it is the crackling flames in a campfire, the roar of a rocket engine, or the ignition of gasoline in your car's engine, combustion is everywhere. We look forward to seeing you in the Learning Commons and in the next video. Goodbye.